What up? It's your boy C. Rizzy coming at you with Unit 4, Lesson 1, Congruent Figures. Our essential question of the day is how can you identify corresponding parts of congruent triangles? And our objective is to recognize congruent figures and their corresponding parts. Our essential understanding is that you can determine whether two figures are congruent by comparing their corresponding parts. So we want to take two figures, whether it be triangles or any sort of polygon, quadrilateral, hexagon, pentagon, and see if they are congruent. If they're the same, then their corresponding parts are equal. So what is corresponding parts? So here's two lovely pictures of Donald Trump. So I want to figure out what are the corresponding parts of Donald Trump. These are obviously two congruent pictures. They're equal. They're exactly the same. So what pieces of Donald Trump correspond? Well, we can say that his left eye corresponds with his left eye. They're the same exact eye. His right eye would correspond to his right eye. His nose would correspond to his nose. His golden hair would correspond to his golden hair. So you kind of get the point. So the point is that corresponding parts, if I were to group them all together, which I'm going to try and do, group, if I picked them up and put them down on top, oops, let's try this too. So send to front. If I go and put this on top of the other picture, they would match up. So the corresponding parts, just like corresponding angles, would sit right on top of each other if I put them in the same place. So, congruent figures. Congruent polygons have congruent corresponding parts. They're matching sides and angles. When you name congruent polygons, you must list corresponding vertices in the same order. So, the most important part about naming congruent figures is this congruency statement. This is a congruence statement. And this is a very important statement because this statement tells me exactly what parts are equal to each other. So notice how the A is in red. Well, A and E match up. They're the same. B and F are the same. D and H are the same. C and G are the same. So when you write this, you know automatically that A and E would match up, B and F would match up, C and G would match up, D and H would match up. Okay, and then you could say all the sides that are congruent to another. So AB would be congruent to EF. BC would be congruent to FG. CD would be congruent to GH. And AD would be congruent to, or DA would be congruent to HE. And again, notice how everything matches up. The green letters went first, followed by the red letters. Purple's letters went first, followed by the green letters. Okay, everything has to match up. And the easiest way to match them up first is to do it by their angles. So I know angle A would be congruent to angle E. Angle B would be congruent to angle F. Angle C would be congruent to angle G. Angle D would be congruent to angle H. Okay, so if HIJK is congruent to LMNO, what are the congruent corresponding parts? All right, sometimes it's easier if you draw these things so that they look exactly the same. So I'm going to change this so it looks the same. Let's see, I can flip this. I can rotate it. Cool, that looks about the same. Now the other thing is, here's my congruency statement. In my congruency statement, I already know what letters are going to match up. H is going to match up with L. I is going to match up with M. J is going to match up with N. And K is going to match up with O. So I already know that angle H is congruent to angle L. And I know that from the congruency statement. I know angle I is congruent to angle M. I is going to be congruent to M. I know angle J is congruent to angle N, J and N. And lastly, angle K is congruent to angle O. Okay, and the other part that's important when writing these, okay, is now I want to be able to write all the sides that are congruent to each other. So I'm not going to do all the fancy colors. But here I have HK is congruent to, now if I started with H to K, what was H congruent to? Oh, it was congruent to L. So I've got to do L. What was K congruent to? O. That matches up. KJ is congruent to ON. JI is congruent to NM. And IH is congruent to ML. So those are all the corresponding and congruent angles and all the corresponding and congruent sides. Okay, here is triangle WIS is congruent to triangle MKV. What are the congruent corresponding parts? Okay, so if I've got these triangles again, I know that these are going to match up. I know these are going to match up. I know these are going to match up because, again, that's my congruency statements. So angle W is congruent to angle M. Angle Y is congruent to angle K. Angle S is congruent to angle V. And then I can do all the sides as well. WY is congruent to MK. And what all I'm doing is I'm going WY, MK. All right, let's keep with W again. WS is congruent to MV. So now I pick WS, MV. And the last one that I haven't done is YS would be congruent to KV. Okay, one more theorem to talk about is third angles theorem, which just says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So if I told you I have two triangles here, and I told you A was congruent to D, and angle B was congruent to angle E, then I must know that C is congruent to F. Okay, so given. So we're going to prove that these two triangles are congruent. To prove that these two triangles are congruent, I need to prove first that all the sides and all the angles are congruent. So, you know 4 pairs of congruent parts. What else do we need to prove? So I've got 2 sides, I've got 2 angles. So I have to prove at least another pair of angles and another pair of sides. And they've highlighted exactly what we need to find. I need to prove that these angles are congruent, and I need to prove that this side, this L and N, are congruent to each other. So what am I going to do? So if I write my proof, I start off with my given. I can prove Ln is congruent to Ln by the reflexive property. Why can I prove that they're the same thing? Well, if we looked, when we separated the triangles, the lines overlap each other. Therefore, they must be congruent. Okay, I know that these angles are congruent by given. So if I was given 2 pairs of angles that were congruent to each other, then I can assume that these last angles have to be congruent to each other by third angles theorem. And then finally, I have proven all the angles are congruent to each other. I've proven all the sides that are congruent to each other. Therefore, these triangles must be congruent to each other. Okay, so let's try one on our own. Looking at this picture, I got to prove something. I got to prove, if I want to prove that these triangles are congruent, what do I need? Well, I've got all the sides. I've got 2 pairs of angles. I got 1 pair of angles. I just need to prove the other angles. Okay, so reason 1 is given. So I would just put all of this stuff over here into my proof for reason number 1. I'm not going to do that now. All right, well, what other angles can I prove are congruent to each other? I can prove these angles are congruent to each other. I can prove angle ABE is congruent to angle, and I got to be careful here. I said ABE, so I got to pay attention to what does the A correspond to? A corresponds to D, B corresponds to itself, and E would correspond to C. I just want to make sure I write this angle correctly because the order matters. So angle ABE, which is this angle, is congruent to angle DBC, which is that angle, because they are vertical angles. Okay? And then lastly, I can prove that angle E is congruent to angle C by a theorem that we learned before, third angles theorem. And then you would write your proof statement since all the corresponding sides are congruent and all the corresponding angles are congruent, my triangles must be congruent. Okay, so let's try a practice problem. If UVW is congruent to EFC, what is the measure of angle FEC? So what is FEC? FEC. So they want to know this angle in here. Okay. Well, I've got a congruency statement, so I know exactly what corresponds to what. I know already that angle U is congruent to angle E, angle V is congruent to angle F, and angle W is congruent to angle C. So, really, what is angle FEC? It's just angle E. And angle E is congruent to angle U. So, that question mark, so if angle U is 51 degrees, then angle E has to be 51 degrees. All right, that's it for me.